Alright. I know, Jasper. Hey, meow. What we're going to do this time is consider a fixed vector space V. In this case, the vector space of all two columns are vectors which have two coordinates. And then we're going to get a subset of that vector space that has 10 axioms. And that's why it's a vector space. And once I get this set, it tells me that it satisfies some property. And then I want to know if that subset is a subspace. So, first of all, what I need to know is U has to be non-empty. It needs to be closed under scalar multiplication and closed under addition. So basically what I need to do is, the first thing I need to do when I'm solving this is ask myself, what does U actually look like? Let's build it with self-builder notation and actually describe what these vectors are going to have, and then they're going to have a certain condition to get into U. Once I do that, I always pick two vectors and then look at see what they look like. And once I do that, I do the addition of those two vectors and then the scalar multiplication with one of those vectors, and as long as they look the same, we're going to have closure of addition and closure of scalar multiplication, and then therefore it's a subspace. So here we go. Basically, what is U? It tells us U is the set of all vectors in R2 with the first coordinate equal to 0. Is that a subspace? So let's describe what U is. Basically, we want it to make it look like a cat, awfully cattish. And then what we're going to do is we're going to add two cats, and it better look like a cat again. And then we're going to scalar multiply a cat. We're going to stretch one, but it still better look like a cat again. If that happens, and we have a non-empty set of cat-looking things, then it's closed, and we in fact have a subspace. It tells me U is the set of all vectors in 2 space, so it's a column and it has two coordinates, and it says the first coordinate is 0. And I don't know what the second coordinate is, so such that x2 is any real number. This is a subset of our vector space R2. So once I have this, what I have to do is take two vectors in there and then add those two. So first of all, is U non-empty? U is non-empty since 0, which is 0, 0, has its first coordinate equal to 0, so this is definitely in U. So 0 is in U, it's non-empty. Check. 2, technically you have to check that it's a non-empty subset. So if it is a subspace, U will be in, or 0 will always be in there. 2, I need to take two things always. Well, let's do scalar multiplication first. I need to take any real number k, and I have to take a vector x, say, in U. What's that going to look like? That's going to look like, well, since it's in U, it says x looks like this. Its first coordinate is 0. When I scalar multiply k x by the scalar k, what do I get? So this is in U. How does the scalar multiplication get in there? Its first coordinate better be 0, so it looks like a cat again. If it looks like a cat again, it gets in there. It's in the subspace again. We haven't altered it. We've just stretched it or contracted it slightly. So k times x is equal to k times 0x2, which is equal to scalar multiplication is k times 0, k times x2, which is k times 0 is 0. So 0kx2. Does it look like a cat? Yeah. How do you get in there? Your first coordinate has to be 0, so this is in U again. And then we ran out of room, so we're going to move it back up here. And then what's our third condition? We're going to add two vectors. I have to take two things always. Every time we do this, if I'm asked if it's a subspace, I need two guys in there now. So I take an x and a y. You could have used U and V. It doesn't matter what you call them. Once I call them something, how did they get in U? Well, we already know. X had its first coordinate 0, so it has some x2. What does y look like? Its first coordinate is also 0, and then it has some y2, some other second coordinate. Now I add those two things. Is it gonna, when I add those two cats, did I make another cat? Yeah, it's gonna look awfully cattish because 0 plus 0 is 0, so it's in there. So this says x plus y is equal to 0x2 plus 0y2 which is equal to, by vector addition, is coordinate wise 0 plus 0, x2 plus y2. 0 plus 0 is 0, so the first coordinate is 0, and then we have x2 plus y2, which is also a real number. So does that look like a cat again? Yeah, its first coordinate is 0, so it's in U. So this is definitely in U. Therefore, it's non-empty. It is closed under scalar multiplication, and it is closed under addition. Thus, U is a subspace of R2. If U is equal to 0x2, such that x2 is any real number, vectors that have second coordinate in R2, which are the first coordinate is 0, then 1, 0, which equals 0, 0 is in U. So U is definitely not empty set. 2, k times x, if it's in there, is k times 0x2, which is 0kx2, which looks like a catish again, awfully catish, so it's in U again, so it's in there closed under scalar multiplication. Closure of scalar multiplication. And this is non-empty. And third, I need closure of addition. If I take x and y in U, what do I know about them? Their first coordinate is 0. They look catish. If I add those, how do I add those vectors? I add them coordinate wise, so I get 0 plus 0 is 0, and I have x2 plus y2, which is still a real number. So this is in U again. We also have closure of vector addition. Thus, because it's non-empty, we have closure of scalar multiplication and closure of addition. U is a subspace of R2. Coincidentally, what is it? Geometrically, it's all vectors which have their first coordinate equal to 0. It's points on the y-axis.